Hello, I am Padma Mallikarjunan. I am an Enterprise Support Manager at AWS, and I am based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Louise Fox and Adrian De Vera from AWS Support. Can you give us a quick introduction, Louise and Adrian?
Thanks, Padma. Hi, my name is Louise, and I'm a technical account manager based in Amsterdam in the Netherlands. And I mainly work directly with customers on their cloud-based architecture, which includes CloudFront and security as well.
Hi, I'm Adrian. I'm a cloud support engineer based in Dublin, Ireland. I work primarily with AWS customers on web development, security, and content delivery of their cloud. Moreover, I help with their own CloudFront infrastructure.
Thank you for joining us from across time zones. Everyone, today we'll be introducing to you Amazon CloudFront. We will specifically focus on security best practices using the Amazon CloudFront service. Before we get into the details, a quick note to our attendees online. Please use the chat window on the right-hand side of your screen to ask your questions and share your thoughts throughout the episode. We look forward to hearing from you. Louise, can you walk us through what you're going to be talking about today?
Yeah, sure. Thanks, Padma. So the agenda for today, firstly, we're going to be talking about secure access controls, so SSL certificates, viewer protocol policy, origin protocol policy. Then we're going to be discussing restrict access controls, so restricting access to your origin, signed URLs, signed cookies, geolocation-based content access, so restricting based on location. Encryption in transit, so this would be enforcing HTTPS connections for requesting your data at the origin. DDoS mitigation techniques and CloudFront's integration with WAF and Shield. Security with Lambda Edge. Logging and monitoring and the different features and services we have here. Configuration management with AWS config. Compliance and the different compliance types we have that support CloudFront. And lastly, some security best practices from myself and Adrian for CloudFront. So starting with secure access control. Here we have a diagram showing between viewers and CloudFront and also between CloudFront and origin. So what are the different HTTPS connections that we offer here? So between viewer and CloudFront, we have viewer protocol policy where you can choose between HTTP and HTTPS. Redirecting HTTP to HTTPS, which would mean that any of your viewers that are using the HTTP protocol, it will redirect it to a more secure protocol, so that way the communication is fully encrypted. And then lastly, HTTPS only, so any request coming from HTTP will actually be dropped and only HTTPS connections will be allowed. Then down below we have certificate options, so you can, if you want to use the default CloudFront domain name, you can use the default CloudFront certificate free of charge. Additionally, if you want to use a custom domain, you can upload an ACM, which is an Amazon Certificate Manager certificate. And these are free of charge and managed by AWS. You only pay for the resources that you integrate it with. And also IAM certificates. So depending on your use case, you can upload either of these certificates to your CloudFront distribution. Protocol options, you can see here we have several different ones for different security policies. We usually, from a security standpoint, would recommend TLS version 1.2 and up if possible. Then we also have the origin protocol policy, so match viewer HTTPS only or HTTP only. Match viewer HTTPS only would be the more secure ones here again. And lastly, having an SSL certificate on your origin. So if you're using an S3 origin, we actually have certificates managed by Amazon that you can use. And if you have your own custom origin, you can again upload your own certificate or use ACM as well. So moving on here to field level encryption. So field level encryption is, as we previously saw, you can enforce secure end-to-end communications between your CloudFront and origin using HTTPS. So then field level encryption is just basically an additional layer of security here that lets you protect specific data by encrypting it at the edge location using your public key. And this allows your users to securely upload sensitive data to your web servers. And all the encryption, all the data will be encrypted from your edge location all the way to the application in the origin. And only specific applications in the origin can actually decrypt that data. Moving on, Adrian's going to talk about restrict access control.
Thanks, Louise. In continuation of having HTTPS between client and CloudFront and between CloudFront and the origin, one of the security features of CloudFront is restricting access control. To utilize and maximize security features of CloudFront, it would be better to restrict your viewers to only use CloudFront and for them not to go straight to the origin. This will allow CloudFront to distinguish between authorized and unauthorized users and to allow or deny certain requests based on URLs, cookies, query strings, certain IPs, and where the viewers are geographically located from. This also allows your origin not to get overwhelmed with a lot of requests and to prevent and mitigate attacks in the likes of DDoS attack. If you have only allowed CloudFront to access your origin, and when viewers try to access your origin directly, then those viewers will get access denied. On this topic, I will cover using Amazon origins like S3, and also I will go through some custom origins. For using Amazon S3 REST API endpoint, one of the security features of CloudFront is OAI, or Origin Access Identity. What this does is it creates an IAM user for CloudFront, and that IAM user will be used in the S3 bucket policy. Think of this IAM like an ID or identification for CloudFront in the bucket policy. So in the screenshot shown in the slide, there's only one effect, which is allow. Then the only allowed principal or viewer is CloudFront, which is represented by an IAM user. Then the only allowed action is for this CloudFront is to get object, meaning to get content from this S3 origin. And the resource simply says the name of the bucket. So if any other principal, let's say public viewers, that tries to get content directly to this S3 bucket will be access denied, since there are no other principal mentioned other than CloudFront. If you are using custom origin like ELB or EC2 or your own HTTP server, and you want to restrict users to only use CloudFront, first, you would have to configure a secret header in your custom origin in order for the request to succeed. Then you would need to configure CloudFront to pass this secret header in the request, and more importantly, you only want CloudFront to have this secret header. So if the origin did not get the secret header from a request, then the request will not be successful and an access denied is returned. On the screenshot shown in the slide, I have a simple ALB rule. There are two rules actually. The first rule is that if the request has the secret header, then the request succeeds. And the second rule of my ALB or my origin is that when the request has no secret header, access denied 403 is returned. So CloudFront is a feature where it can pass origin custom headers that matches the secret header in your custom origin. CloudFront offers geo restriction where you only allow or deny certain countries to access your CloudFront distribution or website. Use cases for these feature is for regulatory needs or region-based contents or application, or if you would just like certain countries to access your website or CloudFront distribution. So let's say I have a CloudFront distribution set up in the US, Canada, and Europe, and I configured that viewers from the United States are the only viewers that are allowed to access my CloudFront or website application. So the requests are okay. But what if there are viewers from other parts of the world that tries to access my application? So since I have geo restriction for US viewers only, others will get access denied. So geo restriction is for allowing or denying certain countries for accessing your CloudFront. And on top of that, you could use AWS WAF or Web Application Firewall to further restrict certain user agents, IP addresses, and networks. Another restriction feature for CloudFront is by using signed URLs or signed cookies. And one of the use cases for this feature is for paid content like video and demand streaming. Also, if you only want authorized users to access your content. So, for viewers to access your content and the distribution, you would need signed URLs and signed cookies. Viewers would have some sort of subscription file, then that subscription is passed to the origin, and the origin checks it and verifies that it is valid. Then the origin generates a signed URL or signed cookie, back to the viewer, then the viewer uses that alongside with the path and the request succeeds. If an unauthorized viewer tries to access a just file without the signed URL or cookie, then the access denied is returned. As shown in the slide, the difference between signed URL and signed cookie is that signed URL is for one file access only, whereas a cookie can be used to access multiple files. Encryption in transit will be discussed by Louise.
Thanks, Adrian. Before we get started on this, Padma, are there any questions from the audience?
Hi, Louise. Yes, we do have a question from Ramon357. So when you were demonstrating communication between CloudFront and the custom origin slides, I know that you have a demo coming up later on here. And the question is, will that demo cover some of the steps about setting up the custom origin?
Yes, it will cover in terms of communicating between CloudFront and the origin, either HTTP or HTTPS.
That's perfect. Hopefully that answers your question, Ramon357. And also, I had one question of my own here. Can I use my own SSL certificate instead of the AWS Certificate Manager or ACM certificate?
Yes, you can. So if you have your own custom domain and you have your own SSL requirements where you need a third-party certificate, you can actually upload that into ACM directly, and then you can use that with CloudFront. So that would be how that is done. And then also that would be between, let's say, uploading it to CloudFront. And then if you have a custom origin, you can actually upload your third-party certificate directly to that as well. But in the next slide, actually, we'll just be discussing ACM, Amazon Certificate Manager, briefly. So it's always good to see what I guess suits your use case best, because that's pros and cons to using ACM certificates, IAM SSL certificates, and your own custom domain certificates as well.
Got it. Thanks for covering that. And back to you, Louise.
Great, thank you. So here we're going to be discussing encryption in transit with CloudFront. So on the next slide here, we just have some features of CloudFront and the different encryption in transit things it offers, I guess. So we touched on this earlier with the HTTPS communication slide, but basically encryption in transit is just encrypting your data while it is being moved, it is in transit. And what we do here with CloudFront is that you can require that your viewers use HTTPS to request your files, so that all connections are encrypted from your viewers to CloudFront and also CloudFront to your origin as well. So first here we have advanced ciphers. So any high security cipher just improves the security of your HTTPS connections. And Amazon CloudFront Edge servers then and clients will also agree on the most secure cipher to use as part of the SSL handshake process. So that way your connections are always using the most advanced, most secure cipher. Next, we have Amazon Certificate Manager that we touched on earlier. So this is managed by AWS, and it's free SSL certificates that you can request for your custom domain and integrate directly with CloudFront as well. But like we said, there are other certificates you can use as well, so it just completely depends on what best suits your business requirements. We also have OCSP stapling, so this is Online Certificate Status Protocol. And what this does is it actually does a call to check if your certificate is valid or revoked. And what CloudFront can do is it can staple that call, so OCSP stapling it, which basically means that the client no longer needs to handle certificate validation. And this not only improves performance, but also security as well, because it lessens the TLS handshake and there's less communication required there. Session tickets. So session tickets help speed up the time spent restarting or resuming an SSL session. So CloudFront will encrypt the SSL session information and store that in a ticket. So that way you no longer have to request it or restart it each time. You can just resume from where you left off on the same secure connection. Perfect forward secrecy. So this provides additional safeguards against eavesdropping of encrypted data by using a unique random session key. Protocol enforcement, so this is enforcing different protocol types, and as I mentioned before, TLS version 1.2 is what we recommend, that or higher if possible. Half or full bridge connections, this is defining the type of connection you want between CloudFront and your viewer and CloudFront and your origin. So do you want HTTPS the whole way, or do you want maybe half HTTP and then HTTPS? So it really depends on, I guess, you might want to strike a balance between security and performance here. Obviously, from a security standpoint, we would recommend using HTTPS, enforcing it for both sides. But if you have a static page, logos or images that don't need to be encrypted, you might want to reduce the overall latency and use a half-bridge connection instead. So we offer that for both. And lastly, field level encryption, which I touched on earlier. So these will be all the features that we have for encryption in transit with CloudFront. On the next slide, we have DDoS mitigation techniques. So AWS CloudFront, Amazon CloudFront is heavily integrated with WAF, Web Application Firewall, which you can add a web ACL, a WAF web ACL, and this will mitigate any attacks on layer 7. So any DDoS attacks coming in on layer 7 of the OSI model can actually be reduced or mitigated by using WAF with CloudFront. So you can create different firewall rules, and you can block, allow, or count these rules depending on what you want to do and what you want logged and tracked as well. And you can block based on IP addresses, on location, on very specific rate-based ruling as well, whatever you think is best. And yeah, this can prevent against different types of layer 7 attacks, such as SQL injection attacks, CSRF attacks, HTTP flood attacks, SYN flood attacks as well. And it can enhance CloudFront features such as custom error pages and geo restriction. Not only that, but CloudFront is also a very robust proxy as well, and it has what am I trying to say? It has a SYN proxy feature where it can actually validate three-way handshakes before passing them to the application, which would prevent any SYN flood attacks. And it's obviously globally distributed, which has really good attack mitigation capabilities as well. So moving on to the next slide here, we just have a diagram of how this would kind of work, I guess. So here you can see several different computers, a distributed denial of service attack incoming. And as you can see here, you have Shield and WAF integrated with CloudFront. So Shield standard is enabled by default on every customer account free of charge. And this can prevent against layer 3 and layer 4 attacks. And then using AWS Shield Advanced, there is a cost to it, and you do have to enable this manually. But this will be able to help you with your WAF rules, mitigating any layer 7 attacks. And it has other features as well, such as being able to call the disaster recovery team, and pricing features as well. So this then, from CloudFront, you have two origins here. So elastic load balancing and also S3 as an origin. So elastic load balancing would be really good here in terms of scaling your application to be able to handle any increased loads or any form of DDoS attacks, and S3 could be used for any static content then as well. So using Shield or Shield Advanced overall here is just very beneficial to the architecture for mitigating DDoS attacks. Over to you, Adrian.
Thanks, Louise. So now we're going to discuss how programmable features of CloudFront, like Lambda Edge or CloudFront functions, add security features. You can use Lambda Edge and CloudFront functions to intercept and modify requests and responses. And these are viewer requests, origin response, and viewer response. Some security examples of having Lambda Edge or functions to your distribution is by adding HTTP security headers to improve security and privacy for your website. Also, for redirecting unauthenticated users to a sign-in page. CloudFront function is a new feature of CloudFront that was just released last month, and you can code directly in CloudFront without having to go to Lambda. Also, it is faster and way more cost-effective for light operations like adding security headers and redirecting unauthenticated users. And also, you can only use CloudFront function in viewer requests and/or viewer response. On this slide is just an example of using Lambda Edge or function is by adding security headers in the response in the likes of content security policy, refer policy, strict transport security, X content type options, X frame options, and lastly, XXS protection. Another security example is to redirect unauthenticated users to a sign-in page if no credentials were entered. As shown on the slide, this is a sample code on how you can reprogram or recode requests and responses. In this case, it's for Lambda and for redirecting unauthenticated users. So this code checks if there is a session ID present in the cookie, and if there is, the request succeeds. If not, a 302 found redirect is returned and a sign-in link is returned to the viewer. Logging and monitoring will be discussed by Louise.
Thanks, Adrian. So next, we're going to go over some logging and monitoring features and services that are integrated with CloudFront. Monitoring is such an important part of maintaining the availability and performance of CloudFront. So yeah, obviously it's very recommended for security as well, just even to easily debug multi-point failures or monitoring and responding to any potential malicious attacks or incidents with CloudFront. So here we have CloudFront access logs, which I'll actually go into more detail on the next slides, but this is known as CloudFront standard logging, and it can be enabled on your distribution. And we also have CloudFront console reports as well, which is another feature of CloudFront. AWS Athena is our service where you can actually make SQL statement queries on the logs to be able to very easily search them and see what you're looking for. CloudFront real-time logging is AWS Kinesis. So this is a service where you can very easily stream data and you'll be able to immediately, instantly see the logs. I think it's within 1 second, so we've more on the slide as well. Monitoring requests using CloudWatch. So we have CloudWatch logs and also CloudWatch alarms, which I'll also do a use case on after this. But basically this would be monitoring single metrics, and if they go above a threshold, you can be notified of this. Logging API calls with CloudTrail. So this would log all CloudFront related API calls in your account, and CloudTrail is enabled by default. However, if you want to store the logs, you have to create your own trail. And lastly, tracking configuration changes and also resource inventory with AWS config. So on the next slide here, we have CloudFront access logs, also known as standard logging, where you can basically enable this on a per distribution level, and then you can save the logs to an S3 bucket that you can choose yourself. And depending on which distribution it's coming from, you can actually save into different prefixes just to organize it better. CloudFront standard logging is free of charge. You only pay for storing the logs. And on the next slide, you're going to see an example of what these logs actually look like when being queried by Athena. So this is the SQL-based service. So you can search here through the logs, and in terms of a security point of view, you can see the date, the timestamp, the location, like was this location expected, if maybe you're looking up a previous attack that happened, the user agent, which browser is it coming from a bot, and query string as well can also tell you a lot about the incident, if it was an attack or if it was actually a genuine customer. On the next slide here, we have real-time logging with AWS Kinesis. So this gives you information about the requests made to a distribution in real time. Logs are delivered within seconds of receiving the request, and you can use this real-time logs to ingest that data, monitor it, analyze it, and take action based on any content delivery performance. So this is really good. There's also the sampling rate here. Determine the sampling rate 1% to 100%. The percentage here is the percentage of requests for which you want to receive these real-time records, basically. And there's specific fields as well. If you want to receive logs in particular, custom ways, you can set this up too. It can be enabled on a per distribution behavior, as I mentioned before. There's also extra metrics with Amazon CloudWatch, such as error rates. So if you want to see the 400 or 500 errors, and there's also specific cache behaviors as well, path patterns, which you can receive real-time logs for. CloudFront reporting suite. So this is more detailed insight into even more metrics again. If you want to see different requests or error rates to be able to debug a previous scenario and get a full report on what happened. Cache statistics, usage charts, what's popular as well. So top refers is another one. So is a single page maybe being requested a lot of times? This can tell you a lot if it was an attack or not. Were they 400 errors, which would be client-side, or 500 errors, which may be server-side? You can look up these, you can see different graphs and ingest this data as well, which is really handy. On the next slide, we have CloudWatch alarms. So I mentioned this briefly earlier, but you can set up different CloudWatch alarms where you can define your own metrics, and set thresholds for these metrics. So if any changes are made to your CloudFront distribution, or if there's any different errors or something like that, you can actually set a threshold to notify you via alarm, or even to take action if it suddenly goes above or below a certain threshold. So this is a great thing to have if you want more of an automated approach to dealing with different attacks and mitigating them. And all the logs are stored as well. CloudTrail, as I mentioned before, this is enabled by default on your account. However, you can create a trail if you want to save the logs yourself and be able to go through them. But yeah, you can see everything in event history, and in terms of, again, security, you can see event name, IP address, so where did the request come from, at what time, what were they requesting. This can tell you a lot as well about any requests that are made to your distributions and looking for any unwanted actions. So you can see here on the right all of the different API calls made. On the next slide, we have AWS config. So this service is really good for monitoring any changes made to your resources, in this case, your CloudFront distribution. And what it can do is any change that's made, you will receive a recording of this in a configuration item. And you can also set up your own AWS config rules. So these can be rules that are managed by AWS, and they're predefined, and you can very easily just select them, which are just below, and I'll get into that in a second. Or else there's also custom managed rules as well, where you can actually define your own rules using Lambda. So depending on your security posture and your business requirements, what exactly do you want to ensure is, your CloudFront distribution is compliant with? So for example, the rules below are showing, is CloudFront access logging enabled for your distributions? So if it's not, this would make the config rule that you've defined non-compliant, and you will be notified of this. You can even set up auto remediation to this as well. Other examples of predefined managed rules by config are, is it associated with WAF web ACLs? Does it have a custom SSL certificate associated? Or is it using origin access identity, which is what Adrian mentioned earlier? Is this configured if you have an S3 origin, which is just a way to make request your origin more secure as well? So these are different things you can check with config. And lastly, moving on to compliance. Oh, actually, before we get to compliance, Padma, are there any questions from the audience?
Yes, we do. Yes, we do. We do have a few questions from the audience. Thank you, Luis. The question from Princeton Girl 21. Thank you for your question. Can you talk a little bit about CloudFront encryption at rest?
Oh, yeah, sure. So I guess the reason we actually didn't touch on encryption at rest in these slides is because CloudFront is a content delivery network, so we were more talking about the data being moved in transit. But in terms of at rest, CloudFront uses SSDs, which are encrypted they're encrypted at the edge location points of presence, is what they're called, POPs. And it's also, they're encrypted EBS volumes at the regional edge cache location as well. So that is how the data is actually encrypted at rest. There's also function code as well, I'm pretty sure. So that's always stored in encrypted format at the encrypted SSDs on the edge location POPs and in other storage locations by CloudFront as well. In terms of encrypting the data at your origin, you can also set up encryption on S3 buckets or on your EC2 instances using EBS volumes, or there are different ways to that as well. But in terms of just CloudFront at rest, Amazon manages all of that for you. You don't really have to worry about it. It's all on encrypted SSDs that are all internally managed by AWS.
Thanks, Luis. And I'll also post a link to the documentation on this topic as well. I have another question here from Rally63. And the question is, does WAF allow rate limiting, or does it only allow blocking connections?
Yeah, it actually allows both. So you can specify a rate limit or IP addresses as a condition. And what will happen is AWS WAF will set the limit on the IP addresses that match the conditions. So when an IP address reaches that rate limit threshold, then WAF will apply whatever action you assigned, whether it's allow, block, or count, as quickly as possible, usually within 30 seconds, and it will fully block any additional IP addresses after that from the rate that you set.
Got it. That's all the questions on the window. Everyone, please post your questions. We have our experts, Adrian and Luis, here to answer those for you. And back to you, Luis.
Okay, take it away, Adrian.
Now we're moving on to CloudFront compliance. Third-party auditors assesses the security and compliance of Amazon CloudFront as part of multiple AWS compliance programs. These include SOC, PCI, HIPAA, FedRAMP, FIPS, and others, which is for example, PCI DSS for payment card standards, FedRAMP for US government data standards, FIPS for US government security standards, and HIPAA for protected health information, just to name a few. For more information about CloudFront compliance, please visit CloudFront compliance programs links shown in the screen. And now we're going to discuss about security best practices for CloudFront.
So yeah, here are some security best practices for CloudFront that myself and Adrian put together just to summarize everything that we discussed. And a lot of this will be put into play once we start the demo as well. So the first one is what I touched on earlier about configuring HTTP to HTTPS redirects for your viewer protocol policy. And what this is basically is if your viewers are coming in using HTTP, making the request, which is unsecure, CloudFront can then redirect this request to HTTPS, making all of the communications more secure then. Encrypting the traffic between CloudFront distributions and their origins. So first was between viewer and CloudFront, now it's CloudFront and your origin using HTTPS as well. For this you can actually assign a different protocol policy, which I mentioned again earlier. So then lastly, using improved security policies for your HTTPS connections. What I was saying here is the more secure, more advanced cipher that you use, whenever the TLS handshake takes place, they're both going to decide on the most secure, most advanced protocol, and that will make your communication secure.
And in continuation of having HTTPS between viewers and CloudFront to the origin, it is better not for your viewers to go straight to the origin. So if you're using S3 REST API bucket origins, you can use origin access identity. Or if you're using website endpoint or custom origins, you can use CloudFront custom headers to pass these secret headers. Also, enforcing field level encryption for sensitive and confidential content is highly recommended, so that private information and confidential information, like for example credit card or healthcare information, will be encrypted from edge location all the way to the application stack.
Yeah, and then moving away from encryption and onto logging and monitoring. So you can enable CloudFront access logging on your distribution. And as I mentioned before, this is like standard logging. It's free of charge. You only pay for storing the logs. And then other features and services to do with logging and monitoring that are integrated with CloudFront are Amazon CloudWatch for setting alarms, setting thresholds and being notified of this. Athena for making any SQL queries that you'd like to your logs, just an easier way to search for whatever you're looking for, whether it's API call or timestamp or a type of request, anything like that. Kinesis for real-time logging and for streaming and ingesting that data to be analyzed and monitored, and AWS CloudTrail for monitoring any API calls to your CloudFront distribution as well. And you can use AWS config for configuration management, resource inventory, ensuring that your resources are compliant with your different config rules, and if not, how would you like to be notified of this, or would you like any auto remediation to take place?
For DDoS resiliency, CloudFront integrates with AWS WAF or Web Application Firewall and AWS Shield. And to restrict access to content using sign URLs and sign cookies as well. And by using, and on top of that, you can use WAF again and geo restriction. And last but not least, Lambda Edge and CloudFront Functions adds a variety of functions and security features for your distribution and your website. So now we're gonna move on to the demo. So now just we're going through creating CloudFront distribution from the very start. So yeah, so let's get started. So for the origin domain name, you have to specify the DNS name of your origin. It has to be publicly accessible for CloudFront to access this origin. Okay, of course, this is where you were going to store your content. And you can use Amazon S3 as shown a while ago, ELB, EC2, or your own HTTP server that is DNS publicly accessible. For now, I'm going to use one of my S3 buckets. For the origin path, if you have a specific path in your origin that you want CloudFront to get content to, you can specify it here, but for now, I'll leave it as blank. Origin Shield is another layer for CloudFront for caching purposes. And in terms of if there are multiple regional edge cache going to get the content, instead of going straight to the origin, it can just go to the origin shield. Okay, and it has to be close to the origin. So right now, I'll just leave it as no. Origin ID auto-populates depending on the origin domain name. Then restrict bucket access is, since I'm using S3, and if you're using an S3 REST API endpoint, you can use origin access entity or OAI, which creates the IAM user as shown a while ago. And yes, to update bucket policy, of course. Then origin connection attempts just basically tells how many times CloudFront tries to connect if there's an error or CloudFront cannot connect to the origin. For now, I'll leave it as 3. Connection timeout is for each of the try. This tells the maximum seconds for each try. For now, I'll leave it as 10. Origin custom headers is used for origin custom origins. For example, passing in secret headers. Okay, if you're not using S3 bucket, and you can specify the secret name and value here, so that the request will be successful. Without this, then of course the request will not be successful. Then the default cache behavior basically tells between CloudFront and the viewer. So here, for security best practice, it's better to use HTTPS. So here, the second one is if there are any user agents that are using HTTP, they will be redirected to HTTPS. And HTTPS only, meaning HTTPS is the only protocol allowed, and any HTTP will be access denied. So in this case, I will just pick redirect HTTP to HTTPS. Allowed HTTP methods is what your viewers are allowed to do basically in your website and going straight to the origin. For now, I'll just leave it as get head options. But please take note as a security practice, if you're using put, post, patch, delete, please ensure that in your origin, you handle these requests properly so that to prevent any malicious activity, basically, or malicious actions from the viewers. So for now, I'll just use get head and options. A field level encryption, which is for private and confidential information that is passed by the viewer to CloudFront. For now, I'll just leave it as blank. Cached HTTP methods, what are the methods that CloudFront will be cached? By default, get and head will be cached, and you can optionally pick options for CloudFront to cache options. Cache and origin request settings dictates how CloudFront and how long CloudFront is going to cache your contents. So here you can set up your the request headers that you want CloudFront to pass to the origin, the minimum TTL of the object in the edge locations, the maximum TTL and the default TTL on how long the objects will stay in the edge locations. You may also want CloudFront to forward cookies and query strings to your origin, and if you need to, you can configure it. But in this case, I will use cache policy and origin request policy. So, yep. It's basically the same thing as the legacy cache settings. Okay, but this is way more simplified. Smooth streaming, I'll leave it as no since I am not using Microsoft IIS server. And restrict viewer access is from shown a while ago, which is for paid view content like video on demand streaming, where you need viewers to use sign URLs or sign cookies to access your content. You can use either key groups or a trusted signer. Okay. It is recommended to use key groups rather than trusted signer, because you have more control on who can create the the sign URL, sign cookie. In this case, I'll just leave it as no. Compress objects automatically helps your website to render faster. So basically, what this does is, if the object is not compressed and CloudFront sees that it can be a compressed object depending on requirements like content encoding and the size of the file, then CloudFront will compress it. I'll leave it as yes. Okay. Edge functions. You can associate edge functions as shown a while ago, whether it's a viewer response, viewer request, or origin request or origin response. Okay, this is an example of a Lambda code or a Lambda function where I'm adding security headers as shown a while ago on the presentation. Okay, so yeah, strict transport security, access protection, refer policy, and I can just use that ARN and I can just copy and paste that for that particular behavior path in CloudFront. Okay. Enable real-time logging for AWS Kinesis, of course, yeah. For now, I'll just leave it as no. For the distribution settings itself, or just in general, price class dictates what are the edge locations that you are going to use. So for example, if you only need edge locations in US, Canada, and Europe, you can just pick the first one. If you need US, Canada, Europe, Asia, Middle East, and Africa, then you can use the second one. Then for all edge locations, which is the best performance, anywhere, like your viewers anywhere from the world can utilize CloudFront close to their locations. WAF ACL, this is the firewall that you can add to CloudFront, basically for example, to restrict or to allow or deny certain IPs and locations. Alternate domain names. By default, you get a CloudFront link for you to access the distribution. But if you want your own CNAME or you want your own website domain, like for example, example.com, you can specify it here. And for HTTPS connection, you can add a custom SSL certificate from Amazon Certificate Manager or ACM. Yeah, for SNI security policy, it is recommended to use TLSV 1.2 2019 and above for better ciphers or security ciphers between the connection between the viewer and CloudFront. Supported HTTP versions, yes, HTTP 2, 1.1 and 1.0. Default root object. So, for example, if your viewers only hit your website domain without any path in the URL, CloudFront will look for the index.html, which is, it will show the default page. Standard logging, which is one of the security features or best practice actually, to monitor the requests coming into your website or CloudFront distribution. So you can store those logs in an Amazon S3 bucket, and you can add the log prefix if you want to. For now, I'll leave it as no. Cookie logging, I'll put it as off, and enable IPv6. You can enable IPv6 for CloudFront to use IPv6 to connect to CloudFront or not. Yeah. Comment just to before we go to the create distribution, going back to the question a while ago, since I'm using S3, I know it didn't show between between CloudFront and the origin, but if you're using your own custom origin, on the top of the page, you can either use HTTP or HTTPS only to connect to the origin, or you can use match viewer where it will use, CloudFront in order for CloudFront to communicate to the origin, it will use the protocol that the viewer use. For example, whether it's HTTP or HTTPS, then CloudFront will use HTTP or HTTPS to the origin. Okay, so creating the distribution, here it is. You have your distribution ID, the ARN, the CNAME if you have one. Of course, you will have your own domain name. For example, CloudFront.net, basically everything that we have discussed a while ago. Okay. Yeah. So behavior path pattern, this is where you have other paths in your URL, and you can set them up depending on, the objects, like caching the objects, and for different viewer protocol policy or allowed HTTP methods for that specific path file. And also you can add additional Lambda Edge on a specific path pattern or behavior path pattern, which is shown like this. Yeah. Origin and origin groups, you can add or you can add up to 25 origins where your CloudFront needs to get content to. For example, on this on my S3 origin here, as I was saying, going back to the question, if you weren't using S3, there would be an option here on what CloudFront or you want CloudFront to use in order to communicate to the origin, either HTTP or HTTPS or match viewer. But here, since I'm using S3, it's not appearing, and HTTPS is used by default. So going to my Amazon S3 bucket as an origin, so as you can see, it's fully private. Block public access are all turned on. And if we look upon on the bucket policy, okay, I'm only allowing CloudFront, and it's the only principal to get this object. Any other principal other than CloudFront will of course will be access denied. And yep. Yeah, as you can see, my bucket ACL is all private. No one is allowed to list or to get any objects other than CloudFront. Okay, for monitoring, as Louise mentioned a while ago, you can see the requests, the error rate, data transfer, 4xx error rate between viewer and CloudFront, as well as between CloudFront and the origin, which is shown in the 5xx error rate breakdown, and of course origin latency between CloudFront and the origin. And last but not least, cache hit rate as well. There you go. For logs in the CloudFront console, you can see the total requests and the percentage of viewer requests by result type. Okay, bytes transferred to the viewers, which is the successful responses back to the viewer. HTTP status code, which is a breakdown of 2xx, 3xx, 4xx, and 5xx. And the percentage of GET requests that did not finish downloading. This is really important just to see if there's anyone just trying to connect to CloudFront and all of a sudden just breaks the connection just to throttle the requests. So for popular objects report, you can also see the objects that are being get the most, and the top refers as well on where the requests are coming from. Yeah, usage, the number of requests, data transfer again. Yeah, data transfer by destination. Yeah, and then the viewers, you can see who are making the request, whether it's a desktop, bot, or unknown, or mobile. Yeah, and then you can see what are the browsers that they're using, whether it's Firefox or UC browser or Chrome. You can go as far as 60 days, if I'm not mistaken. Bot crawler, yeah, unknown. You can basically filter out on to see what are the kind of users that are trying to get requests to your distribution, as well as operating system. You can use whether they're using Mac OS or Linux or Windows or iOS or Android, as an example. Okay. And lastly, the locations on where the viewers are coming from. And you can highlight the top 5 countries where the viewers are requesting something from your distribution. So now, in terms of the logging, this is the last part of it. Yeah, you can use Amazon Athena as an example, and then when you query them, this is where you see the operations. Just a sample form. So, yep. That's it for the demo.
Great, thanks, Adrian.
Mm-hmm.
Padma, are there any questions before we finish up?
Thanks for the great demo, Adrian. And yes, we do have a couple of questions here on the chat window. So the first question is from Ajit Tasha. Thank you for your question. The question is about AWS Shield and the AWS Web Application Firewall. Can you talk about when you would use one versus the other?
Yeah, sure. So while WAF is that's used to mitigate any DDoS attacks at layer 7 of the OSI model, so the application layer, Shield is more used to protect against any web services from DDoS attacks on layer 3 or layer 4. So that would be the network or the transport layer. So layer 3 or layer 4 attacks would be the ping of death using IMCP, ICMP floods as well, teardrop attacks, SYNAC attacks, SYN flood attacks, UDP flood attacks, reflection attacks. I think that's everything I can think of. And then layer 7 attacks are what I mentioned earlier. So SQL injections, CSRF attacks, and HTTP flood attacks as well. So that would be what CloudFront and WAF could be working together on. We do have another talk in 2 weeks, same time, on Twitch as well, called Architecting for DDoS Resiliency, or we'll actually be talking a lot more about this kind of thing if you would like to join that.
Thank you, Louis. And I also posted a link to the when you use Shield versus WAF on the chat window. Hopefully that's useful, Ajitasha. There was another question from SML Block 66. Thank you for your question. This was about how to use Amazon CloudWatch dashboards and custom CloudWatch metrics. I posted the links on the chat window. Hopefully those links are useful as well. With that, everyone, today we looked at Amazon CloudFront and some of the best practices for leveraging the security features using CloudFront. Thank you to our moderators for posting the registration page for the upcoming episodes, awssupportsyou.splashthat.com. Please bookmark this page and we hope you can join us next time. If there are any questions that were not answered today, you can post them on forums.aws.amazon.com or email us any feedback. awssupportsyou@amazon.com. We want to hear from you and tell us what else you would like to see on the show. Thank you for joining us today at AWS Supports You, and happy cloud computing.